Why don't we get started? And if more people join while we're looking at this, we'll fill them in. Basically, I wanted to welcome everyone. Thanks for joining this session. I wanted to present to you a few ideas for how we can test code in OpenDaylight. There's slightly more than ideas because we've explored them in NetVert and have a test that works like this. The idea is both to share with you what we've been doing, I guess, and encourage you to do similar tests in your respective projects and gather feedback on what you think is missing here, is valuable in this approach to perhaps make it more widely, more generally used. The presentation mixes two separate aspects, and I want to say up front why it mixes it. I'm going to say a few things about testing and how to write tests and why write tests like this. And then we're quickly going to get into a fairly technical, low-level discussion about dependency injection. The reason why these two topics are linked is because to write tests that way, as I'm about to present, you do need to solve the problem of how to wire objects together. So these two topics, which are seemingly unrelated at the upfront, have a connection for the technical necessity of being able to wire objects together if you write these kind of tests. And I'll jump straight in and then probably flip back and forth a little bit between the slides. Please do ask questions at any time, interrupt me, just raise your hand. I'd love this to be an interactive session in this DDF. Today in OpenDaylight we have, as far as I know at least, we have three sorts of tests, kinds of tests. If you know of other types, or if you think this classification is wrong, raise your hand. I'd love to have your input. But from what I can see, I think we have the classical Java JUnit tests. So you write your something utility and you write a JUnit for it that tests that class. My observation is that there is a lot of this in the sort of kernel projects. Of course, Yang Tools has millions, or not millions probably, but lots of them. And I have seen some of these kind of tests in the networking applications, in the higher level projects, but not as many. In something like NetVert, there's entire projects that have no test at all. We have integration tests, which are slightly different. Integration tests are written in Java as well. So in these IT projects, the archetype, of course, has an IT project. They're written in Java and they run in a full OSGi container. So our integration tests today, they use a technical framework called PAX exam. That's not important, but that's just a thing that makes sure that you can fire up a carafe. And so you run in a real environment there. These tests test functionality with Java code in a complete environment, which is valuable. This session is not at all about bashing integration tests. There is a third level of tests, which are the CSIT tests, where we write tests not anymore in Java code, but we actually test functionality with robot suites. There was a session yesterday from a colleague of mine at Red Hat who presented this in detail, how he writes out robot suites and what we do with them today. This is different. This is black box testing of a virtual machine with an OVS running in it, complete Yada setup. The proposal of this session is basically to say we need a fourth type. The more the merrier, right? Joking. We have three kind of tests already. I think we have space to do a fourth type. The fourth type is what I'm tentatively calling end-to-end tests, API tests. The idea of those would be that you test the functionality of one specific bundle. So you're writing your networking code in NetVert, something or the other, and you want to test that really does functionally what it's supposed to do. These tests should focus on covering to a high percentage, ideally 100% or 90% or 80% coverage of one particular functional module, and really talk typically to the API of that module. So if you're testing something that has a public Yang API, has an RPC, what you want to test in these kind of tests on the right is, does this thing do what it's supposed to do if you talk to its API? And assert its outcomes on the system. This outcome on the system is typically either write stuff in the data store, so you could check whether the data store has had the change that you want it to have, or it calls out other systems. So one of the tests that we explored this on is that in something called ACL service in NetVert, it creates a bunch of flows, and it does this by calling out to a service in Genius that creates flows. This kind of test should do is replace the actual service implementation in Genius with a stub implementation and check if that has been called to do the flows that you were expecting. Because you don't want to be testing Genius. You want to be testing, in this case, network ACL service. Just an example, right? You want to be testing one particular project and not run the code in other bundles. You want to call the code in your bundles and see if it has done outside of it the service calls that you expected. The big difference between this, and this sounds somewhat like a JUnit test, right? There's a big difference though, that is that a JUnit test would typically be testing a single class, or maybe one or two classes together. Whereas these end-to-end API tests should be testing an entire bundle wired together as it is in production. So it tests a setup similar to how it would run an integration test, with all the same classes injected, bundles, not classes, but objects wired together. With perhaps some of the external services replaced. So the idea here is that the internal, you have a big difference in your Java classes in the internal classes of your bundle. That's what in the Blueprint, if you've migrated your projects to Blueprint, you do with the bean tag, right? And Tom was explaining this very well yesterday. You have a Blueprint XML. In Blueprint XML, you have two different kind of things. You have bean tags for the objects inside your bundle, and you wire them together, and you say this bean needs that other bean, injected in its constructor, and then you have service references to things that are outside of your bundle. So you're saying, I need, in this particular object of my bundle, I need to get a reference to an OSGi service that runs somewhere else. Give me that, and then I'll call it and do stuff with it. And what you want to be doing in these end-to-end API tests is wire together your bundles, wire together your objects in your single bundle internally the way that you are at the production time, but replace the references to the external services. The way this looks like in practice, this is the example test that we're exploring this on, is something like this. An ACL service test. You inject the data broker, you inject test MDCell API manager. This is an external service. And then you say test, standard JUnit, you do stuff. Given something, in this case, given an interface that's part in the data store, when a new state interface is being created in the data store, assert that something has happened on the external service. What's not visible here is that this line 43 here basically checks an effect on the MDCell API manager. I can show you this in the code over here. So what this basically does, this is the test. This is live in Master of Network today. You can check this out and look around for it, at it for yourself. This basically then checks that if the MDCell API manager get flows, this contains something that was caused by what you did in the when state here. Okay, so this is the injected, this API, this one here, has been injected here. And this test is, go ahead.
The test MDCell API manager, that's part of the infrastructure.
So this is a stub for an external service. So in this case, in Genius, there's an API to create flows. And this is a very, very simplistic implementation of that, which doesn't do anything else than store all the flows that you've created in a list inside. So MDCell API manager, I need to get the source code of this.
Wait a second, but
so go on.
You want to test that those flows were actually written to the MDCell?
No, because that happens in Genius.
Oh, you're not testing Genius?
Nope. This is a testing network ACL service impl.
Okay.
And that's actually a very good question, Josh, because that's sort of the key point. You're testing ACL service impl here.
Yeah.
So you want to cover the code in this bundle. And whether Genius or not writes these flows correctly to MDCell is not the point of this test. Ideally, the people writing Genius should have written a test in Genius for MDCell API manager. Right?
Yeah, the point is to trust your dependencies.
Trust your dependencies. Yeah, that's a great keyword to put it. You trust your dependencies and you write test for what you're doing in this particular project. David.
First of all, I wouldn't characterize things as JUnit tests or not JUnit tests. It's cleaner to call them unit tests or not unit tests because you can write integration tests in JUnit.
Sure.
So your test in MDCell API manager is essentially a manual mock.
Yeah.
Why don't you just use Mockito for that?
I don't use Mockito for that. Great question. Because of how we assert the state that's expected, and that's the next slide. These kind of tests run fast, they're easy to debug, and they serve as almost a sort of literal API documentation. So with these tests, you are really showing what, in this case, the ACL service impl does. And it's very important in my mind that these kind of tests are very, very readable. So if you start having a bunch of Mockito calls in here that says, in the case of a test like this creates a structure of objects. Flows are a tree of objects that is relatively complex. You have a flow that contains some state, that contains statuses inside, and this is nested. If you did this with Mockito, then you would now be saying, mock the MDCell API manager, and then you would be doing a lot of lines of verify that this attribute in the flow is this and that. That's not feasible, because what you want to assert looks like this. The goal of the test is to make sure that this flows got created.
So the test MDCell API manager isn't really a mock, it's a fake.
I think fake is what you call them correctly. Yeah, not stop fake. It's a fake implementation of the flow manager. And what you want to do is check that that fake received flows that are complex. So if you look at this expected outcome here, David, you would agree that writing Mockito verify statements of 550 lines is not typically feasible, right? What we've done is I've actually created a small additional test utility, a sort of a micro framework. It's like 3 classes or something, which allow you to write expected bean outcome. In this case, it's written in this alternative JVMing language called extend. You could do it in something else, but I find this highly convenient because the syntax here is very, very readable. You don't see setters and you don't see builders. There's some syntactic sugar going on here that allows you to write source code. So this is not XML or JSON or something. It's source code that allows you to write very, very, very readable expected objects. And you can then assert with this statement here that what was created in the fake MDCell API manager is what you expected. Let me run this for you and show this. I think the best would be to do a little bit of live coding here. So I'm running this test. Note how this test runs much faster than any integration test ever would. You're not starting a carafe, you're not bringing up something. This runs in about 10 seconds, yeah. Actually, most part of these 10 seconds is spent on bringing up the Yang models in memory. Something going on there that takes quite a bit of time. And it's green, right? And what we'll do is we'll make a change somewhere in the expected objects. We'll make a change here. And we'll say that this is like this, and this here is going to be a different type. Note how the code here has syntax completion because it's live code in this alternative JVM language extend. If we rerun this test now, go ahead. So I've changed the expected outcome.
Right.
Question?
The interaction between the ACL manager and Genius is via API or is it via MDCell?
It's via API.
Because there's a lot of interactions between bundles that happens via MDCell, and this just wouldn't.
In that case, you would use the same test framework because I have a variant of this assertion which lets you check content of MDCell.
Okay.
I have that, I'm not showing it here because it's not yet merged. It will be next week. This is available today in master, and the other utility, there's sort of an equivalent utility to this guy here, which asserts that a certain fake object has been called with something that you've defined here. And you can do the same thing in the same syntax to assert that in the MDCell at a certain path, this stuff is stored, which you would use if the code that you're testing is writing in the MDCell. The point is really write a test for what your code does. In this particular case, the code that you're testing does not write in the empty cell. Genius writes in the empty cell. So we're not testing that. But if your code was going to write in the empty cell, then that's what you test.
Okay. So I think at least in NetVert, most of our interactions are done at this point are done that way.
Right. Fine. There's another utility for that, and
Yeah, okay.
there's an OpenGarret for a very, very similar looking test in Elan Manager that does what you're saying.
So it's interesting that this extend code was auto-generated by some other tool.
Right. Let me get to exactly that point. No, that's basically what I'm showing here with this failure. So I was going to drive it from the failure and then explain where this line here comes from. So I've changed the expected outcome of the flows. And let's see here why this test failed. We get a test failure here, we get a comparison failure, and let's see why it failed. So I'm going to click here, and I can see the failure. This is pretty cool, I think. You actually get here a textual diff of the expected outcome versus the actual outcome. Because what this small utility does, this extend beans utility library that I wrote actually, is that it converts a structure, a tree of objects, into source code string. So if you're writing tests for existing code, which is the case where we're catching up, it would be possible but hard to write these, what was it, 500, 800? These 550 lines. To write these 550 lines by hand would be relatively expensive. You could, but really, if you have existing code and you want to ensure non-regression on this, then having a starting point is convenient. And this is what this assertion utility does. When this line here gets called, and let's just walk through the code, okay? This is assert. This is just a thing that checks for empty. That is not very important. The main point is this one. This assert equals bean takes two objects. Object expected, object actual. And what it does is it looks at the content. There's some reflection going on, basically. It says what's happening in these objects. And it's slightly more than reflection because it knows about Yang beans, which you can't introspect with pure reflection. So this has been tailored for OpenDaylight, so that Yang beans that have augmentations, which you don't reach that directly with the direct reflection of getters, it still works and does the right thing. And it'll turn the expected objects and the actual objects into a string, basically. And if there is a difference in the actual, between the actual and the expected, it'll show it to you in a comparison view in the IDE here. This is simply because JUnit has the support for this. There's no additional IDE plugin that works here. This works with IntelliJ, this works with Emacs or whatever you do, right? This is just because in JUnit, when you throw a comparison exception, there is a way of showing the actual and the expected text like this. Just a trick to use JUnit. And what you get here is really, you see exactly that in line 11, this action value content list, this is a list, this is an extend notation for a list, has 250 instead of 220. And over here, it's an Ethernet type instead of an MPLS label. And this is cool because you really see the expected outcome and the real outcome sort of live in the code when the test runs. It also has the advantage, suppose I hadn't actually written all of this. Let's do this for a second. I'm writing a new test for something that doesn't have test coverage yet. And I would start like this. I'd write a test, and I would say over here, now this is not happy because, well, I'll tell you what, we'll just do it like this. Yeah. We don't have any code yet. We just say we expect something, we don't know yet what we're expecting null. What this will do, obviously, is it will say, well, expected null, actual 500 lines of bean structure, and you can take that as your starting point. Oh no, it doesn't work because it's a null pointer. Oh yeah, this needs a fix. Bloody null pointers, aren't they? We're going to do something about fixing them.
Null, right?
Well, in this case, it's a test.
Yeah.
Yeah. The point is to give this message, actually. So what we see now is that the expected is null, the actual is this, and what you can do, and this is where the comment came from that you picked up on, Tom, is that you can say, oh, let's start by saying, I'm going to assume my current code is correct. This is all wrong because test-driven development would be doing it the other way around. But the fact of the matter is that we have a lot of code that doesn't have test coverage today, for which it's handy to work like this, and then going forward, maintain this, and see actually what effect your changes on the code have on tests. I could copy this, I could take this, I could put this in here. Are you guys seeing what I'm doing? So I'm taking the outcome of the JUnit, and I'm copying, probably should be doing this a little slower, I'm copying the actual output of the assertion. And what's being shown to me in this JUnit here is source code. This is a little unusual, but it's sort of a pattern that I think is handy to use in situations like this. I'm copying the output of the JUnit, the actual, and I'm able to copy that in here. This is extend source code, which I'm suggesting is convenient to use for such data structures. I'm not saying we should writing our OpenDaylight code in extend at all, but for these kind of structures, is useful. If I copy this, if I paste this in here, this is valid extend source code. Right? There's no red in here. I can save this, and I have now the test L pass again. And that's what the comment that you picked up on, Tom, was for. It was saying that this code here has really been actually generated by utility. It wasn't typed up initially by a human. And somehow it's not quite happy yet. What do I do?
You still pass the null there.
Oh, in the test, yeah, you guys are paying attention. Right. Right, this is really what we want to do. I changed the external, so there's two files here. There's the test written in Java, and there's the extend just to hold the expected objects. And I was not calling it at all, so voila, and our test passes. So this is pretty cool. This is a way of doing that. Let me be conscious of time. Go back to my slides. So we've covered this, and we've covered this. And oh yeah, one thing to say is that this extend stuff, there's an IntelliJ plugin available as well, so you can edit the same thing here in extend as well, or you can just not use this. And technically, if your data structure that you're asserting is smaller than 500 lines, perhaps this is not of value. So you can use the infrastructure for the tests and all the wiring stuff I'm now going to go into for the second half of the presentation without using this extend infrastructure. But for 500 lines of flows, this is really handy. So using that for that. This is something to fill at the end. I have some blah blah here about some general test tips that I was going to go towards the end. What I want to talk about now is how do we get a bundle ready to test in this approach for the second half. Do you have any questions about the first part, the sort of asserting data structures and this extend tool thing, and anything about that? Otherwise, we'll move on about that. Go ahead.
What's the exact input for the generator?
It's object, Java lang object expected. And then it does reflection on it. Basically, if you look at the code, you'll find that the assertion utility is a subclass of a utility in a general framework, which has a few tweaks to work with Yang. So there's some hard-coded code in there for the fact that you can find a builder for a Yang object in the same package ending with builder. That's basically been fixed and tested. But you could use it for other objects as well. Have a look at the code or ask me mail. Or, yeah. What's curious about this test? So for those of you not familiar with Network, let me quickly open the Network main code. There is a bunch of classes in here. What I'm testing is this stuff on the left. I don't know how many classes this is, 20 or so. All of this stuff, and all of this stuff, and all of this stuff. That's what we're covering in this 3-line test, which is pretty amazing actually. And how do we get these different objects here, which are the inner objects of the bundle, how do we get them wired? There was nothing at all in the test about this, right? I've just said, inject the data broker and inject this fake external service. Somehow, I had to say somewhere that all of this stuff needs to get instantiated, right? let's talk about that for a minute. How do we do this in production? Today, how do we wire stuff together in our bundles?
Using Blueprint.
We're using Blueprint, right? Thanks to some work done by Tom and others, there's this Blueprint. Let's look at the Blueprint file of this bundle here. Anybody notice anything curious in this Blueprint XML? I'm just trying to help those of you who find it hot in here and wake you up and involve you a little bit. What's special in this Blueprint XML compared to the Blueprint XMLs in all other bundles and compared to the presentation Tom gave yesterday?
No bean.
No?
Yeah, no being, right?
There's no bean in here. Right. And that's not surprising. I've taken off all the bean files from the Blueprint XML. Because we don't need them. Because we're suggesting that for internal wiring, you don't need to put bean tags in your Blueprint XML. You can use annotations. If we look a little bit at the code that we're testing here, we would have a abstract ACL service impl. Now this one doesn't have anything. Let's see. Oh, right, because we have this ingress egress stuff here. So this one here. Yeah, now where is it? I'm looking for the annotations, basically. No, I should have it here. Right, this one is a good example. This one is a something listener waits for data change, data tree changes. And here we have an @inject on the constructor. And we have an @singleton on the class, and we have an @postconstruct on the init, and pre-destroy nowhere. We could have a pre-destroy. Right. What this does is, by putting these annotations on the code, it generates the Blueprint XML for you based on this code, which is very useful and avoids a number of mistakes you could make by handwriting XML, or it keeps it up to date if you refactor your classes. And this is something I'd recommend all of you basically to use completely independent of the test work. It turns out that this is handy for the test work. I'll just explain to you why. But even if you don't care about the test stuff that I've been showing, the extend beans and everything, this particular part I think is useful and would be a suitable next step for projects who have adopted the switch from CSS config to Blueprint, to use this to have less XML to handwrite and maintain in their respective bundles, and go for this annotation-based approach is a useful thing to do. Let me show you real quick how you can do this yourself. There's actually a wiki page that documents it somewhere.
Yeah, I wonder if we should combine that with the other Blueprint, using Blueprint. Really nice to combine them.
You combine them, they get combined.
No, I mean what you wrote up for the annotations you said.
Right?
Put that into the other.
Oh, on the wiki.
Using Blueprint.
Oh, sure. You're just talking about where stuff is on the wiki, not?
Yeah.
Yeah. Happy to.
Yeah, that'd be great.
Yeah. If you remember to drop me a line, then I'll see it, and we'll do it next week.
I'll get with you later.
Yeah, but basically this is a quick documentation for what we've done in NetWord. So you can see the singleton here that you put on a class, you put your @inject on your constructor, you still do the thing that you do today, private, final, another service, in the constructor, assign the service to the service. This is all unchanged. You're already doing this today if you switch to Blueprint. It's just a way of annotating instead of using XML. And what you need to do is one thing. First of all, this dependency here in your pom.xml just gives you access to these annotations. And then you need to put this in the pom.xml, because this is what will kick off the code generation of the Blueprint XML. Of the additional Blueprint XML, I should say. So what actually happens at runtime, to be very clear and precise, is that we'll have this handwritten ACL service XML. You'll keep that. And you've ripped out some 20 lines of beans tags in here. And those are now in another XML file, which got generated by this Blueprint Maven plugin.
Can we look at that one?
Sure. It should be under
So you said you had to
target.
move. Did you do some Maven magic to get it moved over?
Yes, Stephen contributed some.
There's a Maven Blueprint plugin that exists already, and so we've added support for it in the parent.
Okay, but so it's all in ODL parent that moves.
Yeah, you just need to do those two little things that Michael's showing there.
This.
Right, yep.
If you want to know exactly what it does, let me show you like this. Of course, you could just go here, and of course, you could see the effective POM.
Yeah, the effective.
And then here we would find where we're doing Blueprint funny stuff. This is it, Blueprint Maven plugin, and has some configuration. Don't put all of this, okay? Just put this. And then you get Primordial Parent what you need. And
Michael, why do you even need the reference in the blueprint? In the blueprint?
Yeah.
Why do you need the reference tags? Isn't it?
Right.
Because when you inject, you have the full class name in the Java code. So why is it needed?
Right. Because there is metadata in here that you don't have in the annotations. For example, if you look at something like this.
Oh, yeah.
And you mean just these?
Typically about the reference.
Yeah, the references. What if what you want to inject, you want to narrow down the OSGi service you want to inject? What if you need a filter or something like this? I was going to get to that in 1 minute if you like, if you can be closer. Yeah, the generated one looks exactly like the one you took off. I'm just trying to remember where it puts it.
I'm just saying that I would assume that the auto-generator could generate a
Here.
reference to...
It doesn't actually. This is the one. This is the auto-generated one. This is the same thing that used to be at the bottom in the second part of the ACL service XML, handwritten, generated. It just says bean, bean, bean. But at runtime, the Blueprint extender looks at both of these XML files at the same time. So you can reference, you can have cross-references between things here. So this works because this has seen that ACL event listener has an @inject on its constructor, and the constructor takes a data broker.
And so you import it, and you have the full class name. So I wonder why the auto-generator needs it.
Because in an OSGi context, the injection resolution there isn't class-based, it's name-based. And that's why you also see the names there are a bit strange. Well, data broker, that's the usual one, but IMDcell API manager, in Genius, it's usually just called MDcell manager, I think. But that doesn't work because so in the OSGi context, you're looking for a service that has to, it's named, it's not typed.
And so there are ways. There are ways, but there's partly we're trying to suggest a gradual move here. We're trying to say this is a first very, very easy step, which all projects can do right now. You can rip out the bean elements of your Blueprint XML and use annotations. You already saved something there. There are possible next steps. There are possible next steps.
So basically, now I'm looking at this for the first time myself. So basically, what's the ext field? What's that over there?
Which one?
The extension there, field, ext field.
Some Blueprint
Field
extension.
injection. Okay, there must be some extent. I don't know. Okay. Anyway, so this is basically saying that so it actually looks at, all right, so as it looks at the code, it uses the variable names.
Correct. There's a convention here.
Your reference, that becomes your bean ID.
That's right.
So it doesn't make any assumptions about what data broker, it just knows it's a bean ID. It could be in another XML file.
It is in another XML file.
Tag. It doesn't have to be an OSGi service. See what I'm saying?
But when
that's why it makes
in the class itself, you have the exact import.
Yeah.
The exact.
But it doesn't know.
Can I interrupt the discussion?
Yeah, this is API and this is import.
Can I interrupt the discussion? You're right, of course, because I have a few more things I want to show. You're right, of course, that the data is there from which you could look up something in the OSGi registry.
But you don't know it. It doesn't know that. So it doesn't make, it's dumb. It just says, I'm going to generate the bean tag with, you're going to supply data broker for me somewhere else.
So this is the first step with which you can replace the bean tags in the XML. And we can look at what we want to do as a next step to go further. I do want to show one thing before we have that discussion, because what you're alluding to is the sort of how I wanted to wrap up the presentation in the last 5-10 minutes to say where can we go in the future, and there's other frameworks where you can do OSGi service injection with annotations. There is stuff like that. Before we talk about that, one thing back about the tests. Now that we have annotations in the source code, now that we have this here, we have two advantages. We have the advantage that we have less in the XML, the Blueprint XML, which is nice, but there's a more important reason, and which was actually the motivation why I did this work. We can leverage this somewhere else. That's the point I'd like to drive home for the next 5 minutes. So we want to write tests, and in the tests we want to wire objects. And our wiring metadata used to be in Blueprint XML or ACL Service XML before. Now it's split in 2 XML files, and it's in the source code. So we need some way of wiring all of the objects that we have here in this implementation, all of this stuff, correctly together, so that in this test, we can run these 3 lines, right? And the cool thing about using annotations is that these annotations are standard. This @inject is not actually a blueprint-specific annotation. This is javax.inject.inject. This thing here, @postConstruct, is javax.annotation.postConstruct. So these are JSR standardized annotations, and we can leverage these annotations with other dependency injection tools. So in the test, we don't actually do anything that has anything to do with Blueprint. This works for Blueprint, and it gives us consistency because we've annotated this code, we've generated XML, and it works as before. It's very low risk. You can move your bean tags of your Blueprint XML that you have in your code today over to annotations, and you go back next week. It highly unlikely breaks something because it does the same thing. It just generates an XML file that you used to type before. But the advantage you get from making this migration is that in this test here, I can use a dependency injection framework which supports this JSR for dependency injection, and use that to wire my objects. It turns out that a bunch of available dependency injection frameworks in Java can wire objects based on such annotations. So if any of you have heard things, probably worked with things like Spring in past lives, other jobs, other companies, there's a thing called Google Juice, which is a dependency injection framework used heavily at Google. There's another dependency injection framework called Dagger, which is the latest kid on the block, new dependency injection framework, originally from Square, today maintained by the good folks at Google. These are all the different dependency injection frameworks that wire objects together based on annotations, and in some cases additional metadata. So one thing that's different in Blueprint, which comes out of the original vision of Spring, and in something like Juice, which is the one I happen to have chosen for this. The point I want to try to make is that you could use another one, but I happen to have chosen Juice because I found it to be meeting the requirements I had to do this work. There's one difference between how Blueprint, which is really just Spring, does the wiring, and Juice does the wiring. That is that in Blueprint and in Spring, there is auto-discovery of beans. So you don't actually say in Blueprint that some bean implements a service interface. It goes around and it says this thing is impl some interface, and it discovers basically beans itself. There's no place where I annotated this bean here with @singleton, and it turned into what we saw here, right? This just happened because it scanned everything. This directly causes this. Because it basically goes around your class path or source folder, the Maven plugin, and says, oh, there's an @singleton here. That's going to be a bean. And in other dependency injection frameworks, including Google Juice, that's not the case. You're actually saying what you're binding with what. And I'm going to show you this. There's actually a code here. Whoops, hang on. There's code here. Maybe I can just take off the green. The green is test coverage, which is cool to use, but not that useful to. Right, there's the Eclipse setup tool that some of you know I've built, has this integrated coverage tool that allows you to see test coverage. Take this off. This here is the wiring that you need to put in to tell Juice that an ACL service manager is bound to ACL service manager impl. Please ignore this stuff here because that's no longer required, because I have actually put this somewhere else in a central place. That's just not merged yet. We're looking at master. You don't need any of this. This stuff is also automatic. But you do need this. You do need to tell a dependency injection framework such as Juice, and it's similar in other ones. It would be similar with Spring if you use Spring config, which is a Java API that replaces XML files. Unless you use class path scanning, you're explicitly saying which are the things that you're binding. In the case of something like this, a service that has an implementation, you're saying the service interface ACL Service Manager, which is an interface, is bound to ACL Service Manager impl, which is a class that implements that interface. And in the case of these listener guys, they're not implementing any particular interface. Well, they are, but that's not the point of them. But you do need to tell your dependency injection container, in this case, that for the test, when you bring up this juice, they call it module, these beans should be bound in it. And this, at first, if you're coming from, whether you're an enterprise Java developer and you're coming from Spring with auto bean discovery through class path scanning, or whether you're an OpenDaylight developer and you're coming from Blueprint XML, actually from Blueprint XML it's probably less shocking, because in your Blueprint XML you also listed all of your beans explicitly. So really this is just doing what you did in your XML in this source code. But it can be surprising, is like, why do I have to write this? And the reason why we're doing this is because for the test we have two modules. We have an ACL service module. This does the binding equivalent to what's in the XML. We have another module that's more interesting. This module here is the ACL service test module. And in this one here I'm doing very specific binding where I'm replacing, well not really replacing, but I'm binding things to fake instances, or let's take this one here. We're binding the data broker to an instance from the data broker test module. This is the same thing as the, in older tests, there's a parent journey class that you can use for this. I forgot what it's called. Data broker test or something? Abstract?
Yeah,
Abstract data broker test or something like this. There's a parent class that you use to get MD cell store test environment available. This does the same thing. But JUnit parent classes are not very nice because they don't allow you to mix things. So you use this to bind the data broker to instance like this. Or for example here, we're binding the ACL service config to ACL service config. ACL service config is this Yang generated interface to look up configuration for this service. And what we can do here is, instead of looking it up from the data store with the original implementation, we can just say bind this interface to ACL service config, which is actually a method we have in our module. And here we can use Mockito. We can say, well, we can mock this ACL service config. Whenever somebody asks for the security group mode, we return security group mode stateful. And this is cool because as you write these API end-to-end tests, you can use one module, and this is just for clarity, you could put both in the same class, but I think it's useful, especially for a tutorial session like this for the slides. You have one module which gives the inner wiring, everything that is in your project that is under test, and you have another module where you declare basically what comes out of the Blueprint XML. Does that make any sense? What I'm doing in here is sort of like at production time what's happening in here. Right, this is telling us that the data broker here needs to be looked up in the OSGi service registry. And that the MD-Cell IPA manager, the thing that pushes the flow, which is in Genius, needs to be looked up in the MD OSGi registry because Genius registered it there. We're replacing that in this little class here, it's 10 lines. And here we're saying that we're binding the MD-Cell API manager to an instance of the test fake. And we can basically wire our objects together via explicit single lines of Java code here, however is convenient for our test. And this explicit control is important. You don't want too much auto-discovery, auto-magic. You want to say, in my test environment, for this easy-to-run test, this needs to be bound to this needs to be bound to that. And that's what these two module classes do.
Who runs this?
This gets run by the test, because there is something in here which I don't want to show because this is not going to be there anymore because it's being refactored in a generic artifact.
Yeah, the important thing to...
Is that your question?
Is that you're not actually rewriting the wiring, you're instantiating the beams and then the dependency injection framework does the wiring based on all the annotations that are shared with the Blueprint stuff. And that's the really interesting part.
That's right. Yeah, thanks for pointing it out. So this, let me make the link from the two classes, and that's probably important to point out that what you're writing in these modules, these juice modules, in the case of using juice, so this class here and this class here gets used over here, for example. So we're getting an ACL Service Manager injected here by Juice, and it will be the one that we registered here. Does that make sense? And this happens because, I'm not sure if that was your exact question before, this happens because in the test, we're saying with a before rule that we need to do this stuff. Except that this is going to be one single rule. This, don't copy this. Just give me a few days because this will be replaced by this. There's a Garrett here, which I want to show you 1 second. Hang on 1 sec. Then I know this comes across as slightly still under development, but it's there, you can use it. This Garrett here, which will be merging in a few days, simplifies this setup here. These lines here get replaced by this line. So in your tests, you can say add rule, juice rule, new juice rule, and then here you put your modules. And this is just a way of encapsulating what's happening here. What this does is it says, bring up the test module and bring up the ACL service module, and tell Juice that this is what it means, how defined, and then like Stephen is pointing out, use this to instantiate all of the annotated classes. The same way the Blueprint does, because Blueprint is using the same annotations. Am I making any sense here? How you're reusing the annotations that you're leveraging for Blueprint for writing tests. And it'll do things like this as well, because there's an add post construct here, which is the same thing as in the Blueprint XML over here. There's some init methods. As you all know who wrote Blueprint, there's some there's some methods here, right? Destroy methods and init methods. And this one here. That also gets called because this, of course, this init method equal init has been generated because there was an add post construct annotation here. And we honor that as well in the juice-based test setup. We see that there's an add post construct annotation here, so we call the init methods and all the listeners. We don't have to do this in our test. That would be stupid. If in our test we would have to, over here, start initializing all of our listeners, that would be a shame, because we have the metadata that all of these listeners need to be, have init methods and need to be called on startup. We can actually let Juice do that. The dependency injection framework can do that for us, just like Blueprint does it for us in production. Okay. Some of this is probably fun to look at home. If you're interested in this, basically walk through the code and it'll make sense. Ask questions on the list if you want to know more about it. These slides illustrate what I have basically walked you through in the code. Right, and the last part, for the last 10 minutes, I was going to have a quick discussion on the point you raised earlier, Guy, which is, so this is the current state of affairs. This is available. This works. You can write tests next week with this. We have it in Network. We're going to write more like this in Network. Some people in the room will help expand the coverage we have for this. We could push this further if we wanted to. I personally don't think it's a high priority to push it further because this works, and you don't actually duplicate a lot of things here. You leverage the annotations that you use for the Blueprint for the tests as well. So this is pretty nice already. There are ways to push this even further. There are other dependency injection frameworks. There are Blueprint annotations which would allow you to not even have this. There is stuff like that. We could explore that separately. It's not really related to the work being done here. There's even something else in Blueprint. Jamie would know, of course, about declarative services and annotation-based declarative OSGi services, which is sort of an alternative to Blueprint. I personally happen to think that there's one thing that declarative services does very differently than Blueprint, which is good, but I'm too shy to propose that we change at this point because I know many of you have just learned Blueprint and perhaps this is not a good time to change
it's
it.
the extensions.
It's the extensions, yeah.
Which is, we'd have to rewrite them as utility or.
Right, yeah. You need some Java API for them or custom annotations, or that's not really the message I want to pass here.
Also your clarity that you're going to lose. BP, you see exactly what services, what beans you have involved.
Right.
And you know what's going on, but if you're doing all annotations for DS, Now you might be across many services and bundles to see what your picture is, and that's going to be a very big challenge given the scope and size of OPL and all the sub-projects.
Right. So we could move till here and basically do this across other projects if you find this a useful approach. And yeah, to answer the question you asked half an hour ago, there would be some things left in here, which theoretically it looks like this could also be deducted from the interface. But hey, this is typically relatively small. So if you look at what you're doing in your bundles, in your projects, you have your internal wiring, which this talk proposes you rip out. And then you have your external wiring. And even in ODL, where we have a big code base, we don't have tens of external services typically. The external wiring is a bunch of services. You need a data broker everywhere, because everything's based on MD-Cell. Then you have some services.
Actually, there's a fair amount. You don't use that much at one point, but there's a lot of different ones.
But not per project. One given project that you migrate, this is not going to be hundreds of lines.
No, I'm just talking about what he brought up. Is always, I find at least, the problem with data, inversion of control in general is it makes a whole bunch of things that were explicit implicit. And so I like the explicitity
that you see.
Real word.
You can mix and match
You see here.
stuff.
Right.
Craft 4 itself is DS under the hood now. We used to be BP under the hood. Now Craft 3, which is what ODL is on. Then we moved it over to DS under the hood for all of our commands. Now we start up and how everything comes together pretty under the hood components of Craft. So it does work well, and it's very easy for us to use, and it's very deterministic in how things are going to be wired together and start up and start in order. So that's great. But from clarity point of view, if you're trying to understand what's going on, you really have to get a good picture of what's going on across all of these projects. So that's the real challenge. That's the disconnect.
If you have a very simple project where your wiring is really trivial, then for these tests, you could even write them without using Juice. I think for something medium complexity like this one here, it's already worth writing this code here. But you could technically write what's done in here in the test explicitly. You could use, if you're really convinced that this is sort of overhead and you don't understand anymore what's being injected from where, it's perfectly possible to write a test for a simple ODL project where you take your 3 classes and you wire them together in your @before setup method of your test and then run it like this.
I mean,
So
one thing I think that also doing the wiring using annotations would be good is we could put it into the Java doc. We could write a Java doc plugin to actually build a graph of it, which would be.
Yeah, there's some runtime information that it's hard to find statically at build time, but depends on.
Okay.
But you could exploit. I think you're saying for documentation purposes, this sort of stuff could be exploited, right? That's basically your message.
Yeah, I think so.
Possible, yeah. Yeah. David, you had a point. We're sort of coming up on time now, so thanks for.
Use instead of Spring. Can you explain why?
Because Spring is really an application platform that has a lot more things in it. You have Spring Core, which is just
It has all the modules.
a single has this module. You could have very well done this with just Spring Core and Java config.
Use a different JSR for the annotations?
No, they sorted it out meanwhile. You can use the standard JSR,
You
I
don't
think.
have to do the manual binding, you can use class path scanning.
Right, which is a bad thing. Because, and you're welcome to write.
Maintain those bindings.
Yeah, well, you're welcome to write your test in a different style. For something like this here, I want to control what I'm binding my ACL service config to. I don't want it to be auto-discovered on the class path. So I happen to, but this is one of the, in development we have these camps and different ideas for different things, and this is one of the classic things where people agree to disagree, auto-discovery and explicit binding. I happen to think it's actually useful that you decide which interface you bind to which implementation to write tests.
Makes it more deterministic.
It's more deterministic, and this auto-discovery stuff, and then where do you tell it how much to scan for, and you have like a class path, and it starts going around and discovering beans in your dependencies, and yeah, I know you can limit by package.
By the package structure.
Yeah, I know you can, Go ahead and write your tests with a different approach. I happen to think this is better. Seems like some people at Google agree with something like this and are fundamentally against putting auto-discovery into their dependency injection framework. So there's different opinions about it.
Readable like that.
Yeah. This is sort of clear what's happening, and yeah. this is one of the questions that people, yeah, I know that you probably in a different camp on this, but do you think this is useful, interesting? Anybody of you motivated to try out some of the different things that I've shown here, whether it's the annotations here?
I think generally, as a developer, when I'm writing code, I don't want to write XMLs.
Right.
I want to write Java code. So anything that makes me not go to XML is better.
Less Java code, you're all for.
My
Right,
experience.
right. So you're definitely going to adopt this in your project. Cool. That's good to see. I think there's basically 3 separate things that I showed here that you guys can take home. Let me just repeat them and then we'll close up for today. I think the first thing that you can do here is use these annotations. You seem to like doing this, and this is what's documented on this wiki page, just to repeat what I said before. And I can move it to the Blueprint main documentation. It's really simple. As we said earlier, you add this dependency, you add this build plugin, and you can start using annotations. That's the first thing. Second thing is writing tests for for comparison of large object structures. That was this part here. There's a test utility that you can use for this. And the third part is that if you want to write end-to-end API style tests and wire them together, you can use this dependency injection based on Juice that leverages the annotations that you migrated to in the first step. Have fun with this. If you have questions about it, feel free to raise it on a mailing list. I'll try to be responsive, or even contact me directly. Or what you can also do is basically just watch out in network what we're doing. I expect that over the next few weeks we'll be pushing this a little further and get inspiration from there. Thanks for your interest. Thanks for your time. Functionally what it's supposed to do. These tests should focus on covering to a high percentage, ideally 100% or 90% or 80% coverage of one particular functional module, and really talk typically to the API of that module. So if you're testing something that has a public Yang API, has an RPC, what you want to test in these kind of tests on the right is, does this thing do what it's supposed to do if you talk to its API? And assert its outcomes on the system. This outcome on the system is typically either write stuff in the data store, so you could check whether the data store has had the change that you want it to have, or it calls out other systems. So one of the tests that we explored this on is that in something called ACL service in Network, it creates a bunch of flows, and it does this by calling out to a service in Genius that creates flows. This kind of test should do is replace the actual service implementation in Genius with a stub implementation and check if that has been called to do the flows that you were expecting. Because you don't want to be testing Genius. You want to be testing, in this case, Network ACL service. Just an example, right? You want to be testing one particular project and not run the code in other bundles. You want to call the code in your bundles and see if it has done outside of it the service calls that you expected. The big difference between this, and this sounds somewhat like a JUnit test, right? There's a big difference though, that is that a JUnit test would typically be testing a single class, or maybe one or two classes together. Whereas these end-to-end API tests should be testing an entire bundle wired together as it is in production. So it tests a setup similar to how it would run an integration test, with all the same classes injected, bundles, objects wired together, with perhaps some of the external services replaced. So the idea here is that the internal, you have a big difference in your Java classes in the internal classes of your bundle. That's what in the Blueprint, if you've migrated your projects to Blueprint, you do with the bean tag, right? And Tom was explaining this very well yesterday. You have a Blueprint XML. In Blueprint XML, you have two different kind of things. You have bean tags for the objects inside your bundle, and you wire them together, and you say this bean needs that other bean, injected in its constructor, and then you have service references to things that are outside of your bundle. So you're saying, I need, in this particular object of my bundle, I need to get a reference to an OSGi service that runs somewhere else. Give me that, and then I'll call it and do stuff with it. And what you want to be doing in these end-to-end API tests is wire together your bundles, wire together your objects in your single bundle internally the way that you are at the production time, but replace the references to the external services. The way this looks like in practice, this is the example test that we're exploring this on, is something like this. An ACL service test You inject the data broker, you inject test MDCell API manager. This is an external service. And then you say test, standard JUnit, you do stuff. Given something, in this case, given an interface that's part in the data store, when a new state interface is being created in the data store, assert that something has happened on the external service. What's not visible here is that this line 43 here basically checks an effect on the MDCell API manager. I can show you this in the code over here. So what this basically does, this is the test. This is live in this in the sort of kernel projects. Of course, Yang Tools has millions, or not millions probably, but lots of them. And I have seen some of these kind of tests in the networking applications, in the higher level projects, but not as many. In something like Network, there's entire projects that have no test at all. We have integration tests, which are slightly different. Integration tests are written in Java as well. So in these IT projects, the archetype, of course, has an IT project. They're written in Java and they run in a full OSGi container. So our integration tests today, they use a technical framework called PAX exam. That's not important, but that's just a thing that makes sure that you can fire up a carafe. And so if you run in a real environment there. These tests test functionality with Java code in a complete environment, which is valuable. This session is not at all about bashing integration tests. There is a third level of tests, which are the CSIT tests, where we write tests not anymore in Java code, but we actually test functionality with robot suites. There was a session yesterday from a colleague of mine at Red Hat who presented this in detail, how he writes out robot suites and what we do with them today. This is different. This is black box testing of a virtual machine with an OVS running in it, complete Yara setup. The proposal of this session is basically to say we need a fourth type. The more the merrier, right? Joking. We have three kind of tests already. I think we have space to do a fourth type. The fourth type is what I'm tentatively calling end-to-end tests, API tests. The idea of those would be that you test the functionality of one specific bundle. So you're writing your networking code in network something or the other, and you want to test that that really does. Why don't we get started? And if more people join while we're looking at this, we'll fill them in. Basically, I wanted to welcome everyone. Thanks for joining this session. I wanted to present to you a few ideas for how we can test code in OpenDaylight. There's slightly more than ideas because we've explored them in Network and have a test that works like this. The idea is both to share with you what we've been doing, I guess, and encourage you to do similar tests in your respective projects and get a feedback on what you think is missing here or is valuable in this approach to perhaps make it more widely, more generally used. The presentation mixes two separate aspects, and I want to say up front why it mixes it. I'm going to say a few things about testing and how to write tests and why write tests like this. And then we're quickly going to get into a fairly technical, low-level discussion about dependency injection. The reason why these two topics are linked is because to write tests that way, as I'm about to present, you do need to solve the problem of how to wire objects together. So these two topics, which are seemingly unrelated at the upfront, have a connection for the technical necessity of being able to wire objects together if you write these kind of tests. And I'll jump straight in and then probably flip back and forth a little bit between the slides. Please do ask questions at any time, interrupt me, just raise your hand. I'd love this to be an interactive session in this DDF. Today in OpenDaylight, we have, as far as I know at least, we have three sorts of tests, kinds of tests. If you know of other types, or if you think this classification is wrong, raise your hand. I'd love to have your input. But from what I can see, I think we have the classical Java JUnit tests. So you write your something utility and you write a JUnit for it that tests that class. My observation is that there is a lot of master of network today. You can check this out and look around at it for yourself. This basically then checks that if the MDCell API manager get flows, this contains something that was caused by what you did in the when state here. Okay, so this is the injected, this API, this one here, has been injected here. And this test is, go ahead.
The test IMDCell API manager, that's part of the infrastructure
So this is a stub for an external service. So in this case, in Genius, there's an API to create flows. And this is a very, very simplistic implementation of that, which doesn't do anything else than store all the flows that you've created in a list inside. So IMDcell API Manager, I need to get the source code of
Wait a
this.
second, but
So go on.
you want to test that those flows were actually written to the MD
No, because that happens in Genius.
Oh, you're not testing Genius?
Nope. This is
The
a
network.
testing network ACL service impl.
Okay.
And that's actually a very good question, Josh, because that's sort of the key point. You're testing ACL service impl here. So you want to cover the code in this bundle. And whether Genius or not writes these flows correctly to MDCell is not the point of this test. Ideally, the people writing Genius should have written a test in Genius for IMDcell API Manager. Right?
Yeah, the point is to trust your dependencies.
Trust your dependencies. Yep, that's a great keyword to put it. You trust your dependencies and you write tests for what you're doing in this particular project. David.
First of all, I wouldn't characterize things as JUnit tests or not JUnit tests. It's cleaner to call them unit